Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Mathematics, Paper 5, Probability and Statistics 1 for May-June 2022, and the code is 9709/52. Okay, so let's move on to question number 1. So for question 1, for n values of the variables x, it is given that summation x minus 200 equals to 446 and summation x equals to 6846. Find the value of n. Alright, so first of all, we will start with summation x minus 200 equals to 446. Now, from here, okay, we know that there are n values. That means your summation of the x will be from 1 until n, right? So it will be, you have to add this x minus 200 for n times because there will be n x values. Okay, so from here I can just do expansion. It will be summation x minus summation of 200, okay, equals to 446. So summation x is given 6846. And then just for information, summation 200 means that you add the 200 for n times, alright, because you have n times of the x values, which means this is 200 times n equals to 446. Okay, so from here to get the n, you move this negative 200n to the other side. I will get 6846 minus 446 equals to 200n. So from here, my 200n equals to 6,400. Therefore, my n is going to be 32. Okay, so this is the solution for question 1. Okay, so now let's look at the question number 2. A fair six-sided die has the numbers 1, 2, 2, 3, 3 on its faces. The die is rolled twice. The random variable x denotes the sum of the two numbers obtained. A. Draw up the probability distribution table for x. Alright, so since our x is referring to the sum of two numbers, so by looking at the smallest x here, by looking at the smallest numbers on the dice, smallest is 1. So when you add it twice, that means smallest x becomes 2. Okay, so I figure out the first x will be 2. So this 2 comes from 1, 1. Right, so it means that you toss or you roll 2 times of number 1. So our probability of getting this, it will be 1 over 6 because there's only 1 out of the 6 faces. So now the next is x equals to 3. So when x equals to 3 means that I will get 1, 2 or 2, 1. Okay, these two are the outcomes. Then my probability of getting x equals to 3 will be for 1, 2. By looking at the 1 here, it will be 1 out of 6. But then the probability of getting 2, when you roll each time, it will be 2 out of 6 because out of 6 faces here, you see the 2 appear twice. Therefore, it is 2 over 6. Right? And then now, the first outcome, 1, 2 is same as the, I should say 1, 2 and 2, 1. Okay, here is 2, 1. So 1, 2 and 2, 1 will be giving you the sum of 3. So the probability of getting 2, 1 will be same as 1, 2. It's just the sequence is different. Means that now I will just times 2. Okay, so from here you will get 4 over 36. Right? So then the next is x equals to 4. So when x equals to 4, I will get 2, 2. Or maybe I will get 1, 3. Or 3, 1. Okay, these are the combinations to get the total of 4. So my px equals to 4, it will be, okay, to get 2, 2, by looking at this, right, the results here, there are 2 out of 6 faces. So 2 over 6 times 2 over 6 because they are independent. Plus, to get 1, 3, so 1 is 1 out of 6 times. 6 faces. So it will be 1 over 6 times the 3. I have triple, you will see 3 times, okay? You can see 3 times because there are triple 3 when you roll, when you observe the faces. So it means that it will be 3 over 6 for getting 3. Alright, and then here 1, 3 and 3, 1 will be the same probability, therefore I times 2. Alright, so from here when you calculate, it will be 10 over 36. Okay, so now the next is x equals to 5. So when x equals to 5, to get the total of 5, it will be 2 times 2 plus 3 or 3 plus 2. Alright, so my px equals to 5 will be, the probability of getting number 2 is 2 out of 6 because there are 2 times, 2 out of 6, times, to get number 3, it will be 3 out of 6 because there are 3 times here. Alright, you see the number 3 appears 3 times. So then the probability of getting 2, 3 and 3, 2 will be the same. Therefore, you times 2. So from here, you will get 12 over 36. Alright, so lastly, your x equals to 6 means that the total is 6. This happens when you get 3 for both row. Right, so probability of getting x equals to 6, so it will be 3 over 6 times 3 over 6. Therefore, you are getting 9 over 36. Okay, so since the question is asking for probability distribution table, therefore, we need to construct a table. So, alright, our first column will be the x values, then our first row will be the x values, and the second row will be the probabilities. So my first x is 2, probability is 1 over 6. Sorry, when px equals to 2, it will be 1 over 6 for first and 1 over 6 for second. So it will be 1 over 36. Okay, I miss out this. So here it will be 1 over 36. Now, when x equals to 3, okay, the probability will be 4 over 36. So when x equals to 4, it will be 10 over 36. Then 5, it will be 12 over 36. And when the total is 6, or the x is 6, I'll get 9 over 36. Right? So to confirm that this table is correct, make sure the total of all these probabilities is 1. Alright? So we have solved this A. Okay, now for B, find EX and variance X. So we know that EX is summation X PX. Right? So now by looking at the table, the probability distribution table, so now we need to multiply. Means that 2 multiplied by 1 over 36. The summation here means that it is plus. So plus with the next multiplication. So 3 multiplied by 4 over 36 plus 4 multiplied by 10 over 36. Then plus 5 multiplied by 12 over 36. Followed by the last one, which is 6 multiplied by 9 over 36. Okay, so from here, at last you will get 168 over 36, and I can simplify this to be 14 over 3. Okay, that is my EX. So you may leave your answer in fraction. Now the next one is to get the variance X, we need to get EX squared first. So I will count EX squared first before I get the variance X. So EX squared is basically summation X squared times the P. Okay, so basically you just refer back to the previous calculation here. All the x means from 2 until 6, you just square it and the P remains. Alright, so it will be 2 squared multiplied by 1 over 36 plus 3 squared multiplied by 4 over 36, and then 4 squared multiplied by 10 over 36, right, plus 5 squared multiplied by 12 over 36, and the last is 6 squared multiplied by 9 over 36. So from here, you will be getting 824 over 36. Right? So at last, your variance X will be expected X squared minus square of the expected X, square of EX. So now I will get 824 over 36 minus square of 14 over 3. Right? So at last, you will be getting 10 over 9. So this is our variance. Now, when you need to calculate the variance, make sure you get positive value for the variance, right? Because variance cannot be negative and seldom get 0. It will be non-negative for the variance. Okay, so with this, we have completed question 2. Right? So now let's look at the question number 3. So for question number 3, the back-to-back stem and leaf diagram shows the diameter in centimeter of 19 cylindrical pipes produced by each of the two companies A and B. So now you are given back-to-back stem and leaf diagram regarding the readings from two companies, company A and company B. So look at the key. Key 1/35/3. Okay, so here, right? Means the pipe diameter from company A is 0.351. So we read towards the left hand side. At 0.351 centimeter, and from company B is 0.353 centimeter. Alright? So this is for company B, this is for company A readings. Now A, find the median and interquartile range of the pipes produced by company A. Okay, so from this question, we know that it will be 19 readings for each company. Means that from the first until last, there will be 19 readings. Right? So now what we need to do here is for the median, I can say it is half of 19 plus 1 theta. Alright? So that means that is the theta number 10. Because 19 plus 1 is 20. 20 divided by 2 is 10. So theta number 10 is my median. So now the smallest is 334. Right? So we read 1. Alright, so I will just use green color. 1, 2, 3, 4, 5, 6, 7. This is number 1, 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my theta number 10, which means my reading will be 0.355. Okay, so my median is 0.355. Alright, so now the next is interquartile range. So we know that interquartile range is the Q3 minus Q1. So we get the Q1 first. So the Q1 is basically half of the median. Since your median is the theta number 10, right? That means we have 9 theta in the previous readings, right? So before the median, we get 9 theta. So now when we divide this 9 theta into 2 parts, alright, so you can just write another half of 9 plus 1 because it's a half of the median. That means 9 plus 1 is 10. 10 divided by 2 is the fifth theta. So from here, the fifth theta is 348. So I know that this is 0.348. Okay, so this is how we get the Q1. And then for Q3 will be the same. So Q3, now we know that there will be 9 theta from the right. Okay, so these are the 9. So I will say this is the first from the back, from the last, right? This is the second, this is the third, this is the fourth, fifth, sixth, 7, 8, 9. So again, if Q1 is the fifth from the top, that means Q3 will be the fifth from the back, which is here, right? Because I have labeled fifth from the back. So it will be 366. So from here, I will just say this is 0.366. Okay, hence my interquartile range is going to be Q3 minus Q1. So you will get 0.366 minus 0.348, which is 0.018. Okay, so this is how we solve this interquartile range. Right, So now B, it is given that for the pipes produced by company B, the lower quarter is basically the Q1. So this is our Q1. Median is the Q2, right? Or you can just write M. Then the upper quarter will be 0.370. So you are given the Q1, Q2, Q3 for the company B. Just now we have counted for company A. So now B, draw box and whisker plots for companies A and B on the grid below. Okay, so now we have to draw for both, right? So now I will label first. So for your information, right, smallest data is 0.331. Okay, based on here, smallest is 0.331. Biggest value is 0.388. Alright, so now I will have to write down label my range as here is 0.33, then here 0.34, 0.35, 0.36, 0.37, 0.38, and then this is 0.39. Okay, so when I mark for company A first, my median is 0.355. Alright, so 0.355. Okay, here 5. Let's say, right? Then my Q1 0.348. So 348 means over here. This is 348. After that, Q3 366. So 366 is over here. Okay, then I will draw a horizontal line. So these are my Q1, Q2, Q3, and then you need to mark the smallest A. The smallest value for the A is 0.334. Biggest is 374. Okay, 334 and 374. So 334, here is the 4. Right, and 374, this is 4 as well. So now we just draw a line. Okay, then here I will write company A. Okay, so now for the company B, the Q1 is 0.346. 346. 346 is over here. This is 5. This is 6. Okay, hang on. Alright, so now here 346, then the next 352 for the median. So this is 5, 35, then 352 is over here. This is my 352, and then 370. So 370. Right, so I will draw a horizontal line. Okay, then check the minimum B, the minimum value from the B, 331, maximum is 388. Right, 331. So 331, 1 is over here. Another one is 388. So 388 is here. Okay, so now just draw a line to connect the box plot. Alright, so this is my company B. Okay, so that's all for the box and whisker plots for company A, for companies A and B. Alright, so now see, make one comparison between the diameters of the pipes produced by the companies A and B. So now the comparison will based on the box plot or box and whiskers plot that we have just solved. Alright, so from here we know that obviously for the company B, there is a big gap. See, look at here. From the smallest to the maximum, it is having higher range, okay, or higher gap, right, than the company A. So from here, I would just say that the company B, or diameters of the pipes produced by company B have more spread, okay, because the range is bigger, more spread than company A. Alright, so this is what you can comment on the diameters of both companies, the diameters of the pipes produced by both companies. Okay, we will just look at the range, the smallest minus the biggest value. Range is the biggest value minus the smallest value. So if the range is bigger, that means the spread, it is more spread, right? So that's the solution for the C. Okay, now for question 4. The weights in kilogram of bags of rice produced by Anders have the distribution N, means that it is normally distributed, with mean 2.02 and the variance is 0.03 squared. A, find the probability that the randomly chosen bag of rice produced by Anders weighs between 1.98 and 2.03 kilograms. So now from here I will write X is normally distributed, mean is 2.02 and variance is 0.03 squared. Okay, now I let the X be the weights, right? And it's mentioned that the weights is between 1.98 and 2.03. So now you need to count this probability. So now, since your X is normally distributed, means that now we need to standardize it, right? So we always standardize by using 1.98, the X value, minus the mean, 2.02, over the standard deviation. So this 0.03 squared is the variance, right? So if just 0.03 itself, that is the standard deviation. That's why I divide by 0.03. Then once you have standardized it, no more X, but we change those Z. Then here will be 2.03 minus 2.02 over 0.03. Okay, so from here when you count these two values, you will be getting the P is between -1.333 and 0.333. Okay, so now we need to refer to the graph. Let's sketch a graph first. The middle value is 0 because this is symmetrical at 0. One is negative 1.333. Another one is positive 0.333. Okay, so my graph, I need to adjust a bit. So this is my region. Alright. Now, when you refer to the normal table, the region always towards the left hand side. And the line should be positive, which means now, right, obviously, to use the table, I have to use PZ less than 0.333 minus this value, alright, minus the Z less than -1.333. So here I will write PZ less than 0.333 minus PZ less than -1.333. Right, but unfortunately less than the Z less than -1.333 is not available in the table. Therefore I need to draw another graph just for the second probability, which means instead of getting this, right, now I have to flip it. So in order to get this region, the left hand region, I have to flip it to the right side, and then it will be 1.333, and the region becomes more than this value, more than 1.333. So in order to get more than 1.333, it will be 1, which is the total probabilities, minus pz less than 1.333, so that you can use the table to get these two values, right? So from here, I will rewrite, it will be pz less than 0.333 minus 1 minus pz less than 1.333. Okay, and then now you use the normal table to get these two probabilities. So the first probability will be 0.6304, and the second probability will be 0.9087. Alright, so when you calculate all these three values, it will be 0.5391. And now always leave your answer equal to three significant figures. Therefore, it will end up with 0.539. Okay, so this is the solution for this question. Right? So now let's move on to the next question. The weights of bags of rice produced by binders are normally distributed with mean 2.55 kg and standard deviation sigma kg. In a random sample of 5,000 of these bags, 134 weighs more than 2.6 kg. Now find the value of sigma. Okay, so from here, I will let this be y, is normally distributed because it's mentioned in the question, and the mean is 2.55. Then the standard deviation is sigma, so I will write sigma squared. So now, even though you are not given the probability that the y is greater than 2.6 kg is how much, but you are given total bags is 5,000, and out of 5,000 bags, 134 bags will be having that weight, having the weights, right? Therefore, from here, 134 and 5,000, I can get the probability, which is 134 over 5,000. So Py greater than 2.6, it will be 134 over 5,000. Okay. So now, again, your y is normally distributed means that we have to standardize it. So when I standardize, I will get more than 2.6 minus 2.55, which is our mean, over standard deviation. That equals to, now, 134 over 5,000. 134 over 5,000 is 0.0268. So here, now I have to draw the graph to decide where is my line here. Where is this line? Okay, 2.6 minus 2.55 over sigma. Where is it? So now I can get it by looking at the probability. Okay, so you have two choices. The first choice is green color, the line, right? The second choice is the red color. So now you look at here. This is more than. So when more than means it will be towards the right side. Okay, so now you have two choices. So when towards the right side, right, the probability you have to label 0.0268, or you have to label the other one as 0.0268. So for your information, if let's say you consider pz less than 0, so I know that the probability is 0.5 because it is half of the graph, right? Total area of the graph is 1. Half of the graph will be 0.5. So now your probability is only 0.0268. So obviously the orange region is more reasonable, because if you choose the green region, that means it's already more than 0.5. Alright, so this is how we decide where is the region. So now, after I have identified the region, right, which means this value is on the right hand side. So if this is on the right hand side, I can find the value from the table. Okay, because your table, one of the condition is the z value here. This is a z value. It must be positive. So from here, I will write pz less than. Okay, this 2.6 minus 2.55, it will be 0.05. Over sigma, it will be, okay, for the orange region, it is 0.0268. So for the blue region, it will be 1 minus 0.0268. Okay, so from here, I will get, this is basically 0.9732. Right, so when you are getting this now, okay, which is the region towards left hand side, then you can refer to the normal table. So now you can just write from table. So PZ less than 1.93, it will be 0.9732. Okay, so now by comparing these two equations, so we know that 0.05 over sigma is 1.93. So now your sigma is going to be 0.05 divided by 1.93, and you will be getting 0.0259. Okay, which is correct to 3 significant figures. Alright, so that's all for the part B. Okay, now the next question is number 5. In a large college, 28% of students do not play any musical instrument, 52% play exactly one musical instrument, and the remainder play 2 or more musical instruments. The random sample of 12 students from the college is chosen. A. Find the probability that more than 9 of these students, so out of 12, there will be more than 9 of the students play at least one musical instrument. At least one means it can be 1, 2, or more. Okay? So now from here, I need to count what is the probability of playing at least one instrument. Right? So it means that it will be 52% plus the remainder here. So now 100% minus 28% minus 52%, or I will just say the easiest is, okay, if you need to get at least one, so it will be 100% minus do not play, right? That is the shortcut. So 100% minus 28%, it will be 72%, which means my x is binomial. This is binomial because number of students means that it is not this is discrete random variable. So we are considering 12 students, and 72% will be playing at least one musical instrument. Okay, so now out of 12, you need to count more than 9. Right, the probability of x more than 9. So when x more than 9, it will be px equals to 10, or is plus, px equals to 11, or px equals to 12. Okay, so now for your information, binomial x is binomial NP. The probability of getting small x will be NCX, PX, QN minus X. This is the probability. So I'm going to use this formula for the calculation. So I will get 12C10. The 0.72 is the P, and there will be 10. The Q will be 28%. That means it's 0.28 power 2 plus 12C11, 0.72 degree 11, then multiply by 0.28 degree 1 plus 12C12, 0.72 degree 12. Okay, so from here I will get total of 0.304. So that's the probability for A. Now, a random sample of 90 students, just now only 12, now becomes 90. Now, use an approximation to find the probability that fewer than 40 of these students play exactly one musical instrument. So when exactly one instrument means that now your probability is no longer 72%. It will be just 52%. Alright, so I will change it to 0.52. instead of 0.72. So now I let y be binomial because the n has been changed to 90, so I will not use back the x, 90. And then the probability of playing exactly one instrument is 0.52, as I have mentioned just now. So from here, since your n is large, right, that's why you are given the hints using an approximation. So now I need to calculate my NP first. My NP is 90. This is my P. Here is N. This is P. So 90 times 0.52, and I get 60. Sorry, I'm getting 46.8. All right. So from here, since this is greater than 5, which means now we need to use normal approximation. So for normal approximation, your NP will be the mean. This is the mean. Right? Then I need to find my NP, my variance now, which is the NPQ. So NPQ, you can just take 46.8, which is the NP, multiplied by the Q. So 46.8, the Q is 1 minus 0.52. That is the Q. Right? And then from here, you will be getting 46.8 multiplied by 0.48, and the variance is 22.464. I give more decimal places because this is not yet the final answer, it's just a working. So now, by using the normal approximation, so your y will approximate to a new variable w, and it is normally distributed with mean 46.8. The variance is 22.464. Okay, so now fewer than 40. So now you need to count py less than 40. So now be careful with this because at first your question belongs to binomial, which is discrete. And now due to the NP is more than 50, and of course your N is also more than 50, okay, which is 90 here, then we have to use normal approximation. So the normal variable is continuous, binomial is discrete. Therefore, you need to carry out the continuity correction, whereby you have to decide whether you plus 0.5 from the given value or you minus 0.5. So now I will label 40 first because your y is less than 40. But then since your y less than 40 means that the actual value will be 39, 38, and so on. Okay, all these are your actual y. And now you are given two choices. Either you plus 0.5 from 40, which is 40.5, or you minus 0.5 from 40, which is 39.5. And then here I will just write P. Instead of Y, you change to W. Rewrite the less than. Now your choices will be either less than, the W less than 39.5 or W less than 40.5. So obviously to include these two green ticks, I have to choose less than 35.5. Okay? Oh, sorry, 39.5. So it should be PW less than 39.5. Right? So once you have decided your W value, now we need to standardize the W. So it will be Z less than 39.5 minus 46.8 over, don't forget, this 22.464 is basically a variance. Okay, this is variance. So now we need to get the standard deviation, which is the square root of the variance. Okay, then from here, when you do the calculation, you will get negative 1.540. And once you have obtained this standardized normal random variable, quickly sketch a graph, the normal graph, and mark the value negative 1.540. Less than means towards the left hand side. So this blue region is your actual region. But since it is on the negative part, we have to reflect, okay, or we have to flip it to the right hand side. So it means that here becomes 1.540. The green region is equivalent to the blue region. Okay, in order to get the green region, alright, because your region now is towards the right hand side, I have to use total probabilities 1 minus PZ less than 1.540. Then I will be getting the green region. Means that the long arrow minus short arrow, it will be the green region. So I will write P, it will be equal to 1 minus P Z less than 1.540. Okay, so now you can just read the probability from the table and it will give you 0.9382. That is the probability of Z less than 1.540. And at last, correct to 3 significant figures, you'll be getting 0.0618. Okay, so this is the working for parts B. Alright. Okay, so now question 6. Find a number of different arrangements of the 9 letters in the word crocodile. Right? So from here you have 9 letters. Right? So CROCODILE. 9 letters. Out of these 9 letters, I have 2 C. Then I have 2 O. Right? 2 O. Then I have R. Then D-I-L-E. So these are the 9 letters. Okay, and the question just very general. Find the different arrangements of these 9 letters. So now our working will be number of arrangements. This is basically the arrangements without any restrictions, right? So total 9 letters, and since we are arranging all of them, therefore there will be 9 factorial. Now divided by the repeating 2O and 2C. So 2 factorial, 2 factorial. Alright, so therefore you will be getting 90720. So that's the solution for 6A. Right, now B. For the find the number of different arrangements of the 9 letters in the word crocodile in which there is a C at each end and 2 O's are not together. Okay, so now each end. So one C, then okay, now see, you have 2 C's at the end and 2 O's are not together. Initially you have 9. Okay, so this 9 you already included 2 C's. Then you will have another 2 O's. So these 2 O's, to make sure they are not together, means that I have to exclude them first. Then I will have another R, D, I, L, and E. I will have another 5. So I will draw 5 lines here first. These 5 lines will be for R, D, I, L, and E. Okay, so to make sure the 2 O's are not together, means that now my O can be in any of these places. Okay, then if you consider any of these green arrows for the 2 O's, that means the 2 O's definitely won't be together. Alright, so that is the whole concept of this question. So now, when you look at the question, this is arrangements. Firstly, I will arrange. The C already fixed. No need to arrange because they are at the end, right? At each end. So now I just need to arrange for these 5 letters. R, D, I, L, E. Therefore, my number of arrangements will be 5 factorial. This 5 factorial is to arrange R, D, I, L, E. Okay, after that, follow by means times. I need to arrange for the 2O. Alright, just for information, no need to arrange for the 2O. You just choose any 2 from the green arrows. So now from the green arrows, we have 6 there. Right, out of 6, I just choose any 2 places for the O because these 2 O's are the same. Right, so your working is basically 5 factorial to arrange R, D, I, L, E, followed by means times. 6C2 means that the 6 green arrows, you choose any 2 to locate the O. Alright, so at last you'll be getting 1800. So these are the number of arrangements that satisfy the condition. Okay, Now see, 4 letters are selected from 9 letters in the word crocodile. Find the number of selections. So it's different from previous because just now was arrangements. So in which the number of C is not the same as the number of O. So now here, remember we have 2C, 2O, then we have R, D, I, L, E. Right? So you are choosing 4 letters from 9. So what to do is, and you have to make sure the number of C is different from the number of O. So I will say first I get 1 C. Then these 3 are RDI, RDILE, okay, without O. Then probably I get 1 O, another 3 different letters, another 3 from RDILE, or probably I get 2 C and there's no O, because I need to make sure number of C is different from the number of O. Alright, then I can say that I will have 2 C and 1 O. Then another one is not O. Probably I have 2 O and 2 non-C. Then 2 O followed by C and the next one. So now the number of selections means that the arrangement is not important, right? I just need to concern about the letters that I have selected. So for your information, the first case, if you just choose C and the other 3 are not O, okay, means that you have to choose from these 5. Alright, so I will say it is 5, choose 3. That is for the first case. All this will be all. So now for the second one, all is plus, right? So for the second one, I need to get 1 O only. So these 3 are not O, not C. I have to choose from R, D, I, L, E. Therefore, again, 5, I choose 3. Or is plus. Now for the third case, I have chosen 2C. There's no O. Means that these 2 underlines, right, are for not O. Means that I have to choose from the R, D, I, L, E. So from 5, I need to choose 2. Okay? Or for the fourth case, I need to choose 1 from the R, D, I, L, E. So 5, choose 1. Then the next case is I need to choose 2 from the RDILE, so 5, choose 2. Or the last condition, I need to choose 1 from the 5, so 5, choose 1. Okay, so from here, I will just write, this is 5C3, you are getting 10. 5C3, 10. 5C2 is 10. 5C1 is 5. 5C2 is 10. And the last one, 5C1 is 5. So the total is going to be 50. So this will be the number of selections, right? Where the number of C is different from number of O. Okay, now D. Find the number of ways in which 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different groups. Okay, so now our concern is the C. Okay, so I will have, see, I will have 2C, 2O, then I have R, D, I, L, E. Okay, our concern is 3 groups. Okay, let's say for example, 2 C's must be in different group. Okay, first, second, third, right? Or I will say that there are three groups, 1, 2, 3. So 2 C's are on different group, are in different groups. So I will say that 2C in first and second group, this is the first case. Now I need to consider the O. So maybe my O, both O's are on the first group. Okay, are in the first group. Then the second group will be other letters. Maybe first group, second group, I have C. then each group I have one O. Right? Then here, other letters. Then the other one probably I have CO. Then here I have C. Then I have O. Right? So another case may be C, C, O, O in other group. Alright, so these are the 4 possible ways to put them in the groups. Okay, so now the number of ways, so equals to, so for the first group, right? So since COO already chosen, no need to bother anymore. I will consider our second group. Remember, we still have, see, we have 2C, 2O, then R, D, I, L, E. So the C and O already considered means that this all the underlines, remember, all the underlines means either R, D, I or L, E, right? So to consider these two lines, these two underlines, I means that you have to choose 2 from this 5. So at first I have 5, then I choose 2. Okay, then done for the second group. The third group, so let's say you have chosen 5 R and D. That means you still have 5 more left, I, L, E. So I need to choose all 3 and put it in the last group. Therefore, 3C3. Okay, that's for the first combination. Now, here is or. So when or means plus. Now, for the second case, CO already chosen. Okay, so now I have to choose 1 from the 5 letters. Therefore, I will have 5C1 for the first class, for the first group. Then the second group, again, this underline will be chosen from the RDILE. But don't forget, just now I have chosen 1 to be placed in the first group. That means now you only have 4 left. Let's say, for example, you have chosen R. So now I will write 4C1. That is to get the second group. Okay, now then from here you have to be careful. Please take notes on this. Let's say, for example, first one I have chosen R. Okay, second one I have chosen D from the RDILE. So for your information, if you write 5C1 times 4C1 for the first and second group, it is also meaning COR, COD. Okay, these two are the groups. And it could be COD, COR. Right? So when you write 5C1 times 4C1, it will give you both of them. Right? Which means you are counted twice. Okay? So when you are counted twice, in this case, you have to divide by 2. So you have to be careful with this because we are considering the selection. So for your information, when you use C, right, it's like AB and BA is considered the same. But then, so for this case, we have considered twice. Alright. So now we have to divide by 2. So then, followed by the third group. Alright. So the group, no doubt, we still have 3 more left. Therefore, 3C3. So this is the special case. Right? So then, now the next is the third case is when you get CO. So when here's CO, right, we need 1 from the RDILE. So which means it is 5C1 multiplied by, I need 2 from the remaining. So just now I have chosen 1. Let's say, for example, I have chosen the R. So now you still have DILE. So now from this 4, I need to choose 2 to be put in the second group. Then followed by the third group, I need another 2. So if you have chosen 2 just now, that means you still have 2 more left. So now 2, choose 2. Okay. So now the last condition is The last condition is the first one is C. Then 2 letters from the RDILE. So 5C2 followed by, again, 2 groups. The second group, you have 1C and 2 letters from the RDILE. Just now, let's say, for example, we have chosen the R. Then you still have 4 more left. So 4, choose 2. Now, this case is same as the second case. Okay, so let's say, for example, here you choose CRD. And then the next one, you choose CIE. These are the 2 groups. And then when you write 5C2 times 4C2, it's also counted CIE for the first group and CRD for the second group. Okay, so from here you will see that they are repeating, right? Because our concern is the selection, it's not the arrangements. So now from here you need to divide by 2 because it is double count, right? And same for the last one, I need 1 more left, so it means that 1C1. Okay, so these are the special cases for the selection. Alright, so then from here you simplify. So when I simplify, basically the first one when you multiply, you will be getting 10. The second bracket where you multiply, you will be getting 10 as well. Then the third bracket, it will be 30. And then the last bracket, it will be... Okay, wait, I found a mistake. Right, for the last part, the last bracket, you see just now, I have chosen 2 from the 5. Okay, let's say I have chosen 2 from 5. That means I still have 3 more left. It's not 4. It should be 3. Okay, this is a small mistake. 3, you choose 2. So choose another 2, then the last one. Alright, so the last bracket is going to be 15. Okay, let me check any mistake. 5C1, 4C2, and then 2C2. Yes, correct. Okay, so now this will be the working, and then at last you are getting 65. Okay. Right. So now question 7. Hannah buys 12 hollow chocolate eggs that each contain a sweet. The eggs look identical, but Hannah knows that 3 contain a red sweet. Okay, so from 12, 3 red, 4 contain an orange sweet. So orange, I will write it as E. 5 contain a yellow sweet. So 5 Y. Now each of Hannah's 3 children in turn randomly chooses and eats one of the eggs, keeping the sweet it contains. Now A, calculate the probability that all 3 eggs chosen contain the same color. Okay, so probability of same color sweets means that it could be 3R, both are red, all 3 are red, okay, or all 3 are orange color, or all 3 are yellow color. Okay, so now from here, right, there will be 3R in total, so the probability is 3 choose 3 over 12 choose 3, or 3 orange color 3E. So you have 4 E's here, you need to choose 3E. That means it's 4 choose 3 over 12 choose 3, or 3 yellow. So 5 choose 3 over 12 choose 3. Okay, so now 3C3 over 12C3 is 1 over 220. 4C3 over 12C3 is 4 over 220. Then 5C3 over 12C3 is 10 over 220. So from here, you will get 15 over 220. And you can simplify this to be 3 over 34. Okay, that's the probability of getting same color sweets. Right. Now B, find the probability that all 3 eggs contain a yellow sweet. So a yellow sweet, so 1 yellow. Given that means conditional probability, all 3 children have the same color sweet. So this is same color sweet. Okay, since this is the conditional probability, then according to the formula, it will be the intersection over the after slash. Okay, over probability of same color sweet. Alright, so now from here, the probability of 1 yellow and same color sweets. Remember, all 3 children. All 3 children means we have found just now. Same color sweets means 3 white, 3 red, or 3 orange. Okay, so 1 yellow intersect with all these 3. That means it will be all 3 white, right? So it means that you are getting all 3 white. So this is P3Y over P same color. That is the intersection. Alright, so all 3y, just now we have counted the probability. 3y is 10 over 220. Divided by same color sweet, it will be, you can just use 15 over 220 because we can cancel off the 220. So I will write 15 over 220. Okay, so from here, you will cancel off the denominator and you are getting 10 over 15. So 10 over 15 can be simplified to 2 over 3. Right? So that's the solution for this question B. Okay, now the next one. C, find the probability that at least one means it can be 1, 2, or 3, of Hannah's 3 children chooses an egg that contains an orange sweet. Right? So from here, I will write P, at least 1 orange sweet. Means that at least 1 E. Okay, so at least 1 E. Now for your information, Hannah has 3 children, right? So it can be none of them having, chosen the orange sweet. It can be 1, it can be 2, or it can be all 3 children chosen the orange sweets. So now you need to find at least 1. At least 1 means it could be 1, 2, or 3. This will be the sample space, right? All possible outcomes. So I will say that it is same as 1 minus B, no orange sweets. Okay? So this is the complementation rule. Complementation rule. Alright, so if no orange sweets means that now 1 minus, remember just now we have 3R, 4E, 5Y. So I will rewrite this. So 3R, 4E, 5Y. Okay, if no orange sweets, so I exclude this, means that you will have 8 choices, 3R or 5Y. So it means that it will be, out of 8, I need to choose 3, because for 3 children. Then over the total is 12. I choose 3. Okay, so I have 8 choices. Means that I can choose either red or white. Red or yellow. So I have 8 choices. So from 8, I choose 3 because they are considering 3 children. Right? So this is 1 minus 56 over 220. So at last, you will be getting 41 over 55. That is the solution of part C. Okay? Alright, so we have come to the end of the paper. Right? So thank you for watching. Please subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.